Hello students, hope you all are having a very good day. So the topic of today's online session is Introduction to Different Lab Reagents. So in today's session, we are going to discuss about the different types of reagents and chemicals that are used in the laboratories and how they are stored in the laboratory and what is the use of these reagents in the laboratories. We will also discuss that how should we preserve these reagents in the laboratory so as we can increase their shelf life and provide an improved shelf life of these reagents. So without delaying, let's start today's session. First of all, first reagent is the carbon fuchsin reagent. So carbon fuchsin is a mixture of phenol and basic fuchsin. As you can see, it is generally used for the staining procedures of the bacteria. Commonly, it is used for the staining of mycobacteria. It is a reagent which is commonly used as a primary stain in the acid-fast staining. Because why it is used for the acid-fast staining? Because it has affinity for the mycolic acids which are found in the cell membrane of these bacteria. So it is clear that carbon fuchsin is a reagent which is commonly used for staining of the bacteria. It is generally used for the acid-fast bacilli staining, AFB stain. Why it is used for AFB stain? Because this carbon fuchsin reagent has its affinity for the mycolic acid which is found in the cell membrane of the acid-fast bacteria. Now the question arises that how we have to prepare this carbon fuchsin. So for the preparation of carbon fuchsin, 1% carbon fuchsin is prepared from 10 ml of basic fuchsin. This is dissolved in the methanol and 50 ml of melted phenol in a flask, the temperature of which is maintained at 60 degrees Celsius in a water bath. Alright, so you have to mix the 10 ml of basic fuchsin which is dissolved in the methanol in 50 ml of melted phenol and the temperature is maintained at 60 degrees Celsius in a water bath. Alright, this is clear to you. So carbon fuchsin is a basic dye which forms a yellow-brown compound in the presence of acid. It is mainly required for the staining of mycobacteria. The waxy walls of mycobacteria helps in retaining the dye within the cell, and it can also be used for the staining of bacterial spores. Alright, so it is a mixture of basic fuchsin and phenol. Alright, so it comes under the hazards of acute toxicity, inhalation, oral aquatic chronic, etc. Alright, so how you have to perform the staining using the carbon fuchsin? So you have to cover the slide with the Ziehl-Neelsen's carbon fuchsin and heat the underside of slide with a lighted alcohol soaked swab to remove the heat when the slide will steam. So what you have to do, you have to take the slide on which you have prepared the smear of the acid-fast bacteria or any kind of sample that you have received. You have to make a smear of that on the glass slide. Now what you have to do, you have to cover the slide with this carbon fuchsin and heat the underside of the slide with the Bunsen burner. Thereafter, what you have to do, you have to keep it for 10 minutes, 10 to 15 minutes. Thereby, you will wash it well and decolorize with 20% sulfuric acid. After decolorizing, you will wash the slide again and then you will counter stain it with the Loeffler's methylene for 5 minutes. Now second reagent is Gram's iodine. So as the name suggests, Gram's iodine is used for the staining purpose of the bacteria to differentiate the bacteria into gram positive and gram negative. Generally, Gram's iodine is used in the gram staining. Why gram staining is performed? Gram staining is performed to differentiate the bacteria into the gram positive bacteria and the gram negative bacteria. The basic difference between the gram positive and gram negative bacteria is based on the properties of their cell wall, the difference between the cell wall of gram positive and gram negative bacteria. So on the basis of this, what is the function of Gram's iodine now in the gram staining? So Gram's iodine helps in the retention of the primary stain. Alright, it acts as a mordant. It acts as a mordant in the gram staining by helping in the retention of the primary stain well. Alright, now how you have to prepare the Gram's iodine? You have to grind 1 gram of iodine and 2 gram of potassium iodide in a mortar. Alright, after grinding this, you have to add distilled water. Alright, 300 ml distilled water is used. Now what you have to do, you have to mix it well and you have to store this at room temperature or at 25 degrees Celsius in a foil covered bottle and protect it from the sunlight. Generally the amber color bottle is used for the storage of the Gram's iodine. Now talking about the next type of reagent, which is Giemsa stain. So Giemsa stain is named after German chemist and bacteriologist Gustav Giemsa. Alright, so what is Giemsa stain? Giemsa stain is a nucleic acid stain which is used in the cytogenetics and histopathological diagnosis of material and for the diagnosis of other parasites also. Alright, Giemsa stain is used for the Giemsa staining which is also performed in the hematology department. The Giemsa stain is also performed in the histopathological department and also for the cytogenetics. Alright. Now how you have to prepare the Giemsa stain? So you have to dissolve 1 gram of Giemsa powder into 54 ml of glycerine. You have to heat this solution at 60 degrees Celsius for about 130 hour to 2 hour. Then you have to let it cool at the room temperature. Then after reaching at the room temperature or after cooling, you have to add 84 ml of methanol to it. After adding the methanol and mixing it well, you have to close the bottle very well and protect it from the light for 1 week. After 1 week, you have to filter the solution again and keep it protected from the sunlight by preserving it. Alright, so this is the procedure of preparation of the Giemsa stain. Alright, now talking about the crystal violet. So crystal violet solution, which is also known as gentian violet, is a protein dye. It is generally basic in nature. Crystal violet is used for the Gram staining process, for which I discussed that Gram staining is used for the differentiation of Gram positive and Gram negative bacteria based on their difference in the cell wall. So crystal violet is used in the Gram staining as a primary stain which provides a deep purple color to the cell wall of the bacteria. Now how crystal violet is prepared? So to prepare the crystal violet stain or solution, you have to dissolve 2 gram crystal violet powder in 20 ml of 95% ethyl alcohol. After dissolving it properly, you have to dissolve 8 gram ammonium oxalate monohydrate in 80 ml deionized water. Now mix the crystal violet and ammonium oxalate monohydrate solutions that you have prepared separately, and if you feel that you have the need to filter the stain again, and then you can start using the crystal violet stain for the Gram staining. Alright, now talking about the Leishman stain. So Leishman stain is also used for the microscopy of blood smears, for staining the blood smears. To observe the blood smears, what we have to do, we have to take the Leishman stain and stain the blood smear that we have prepared with it. So it is generally used to differentiate between different types of blood cells, malaria and malaria parasites and other parasites also. Alright, so how you have to prepare the Leishman stain? For preparing the Leishman stain, you have to take 30 ml of Leishman stain and mix it with 150 ml of distilled water with 20 ml of pH 6.8 buffer solution. You have to take 30 ml of Leishman solution plus 150 ml of distilled water plus 20 ml of buffer solution whose pH is 6.8. Now what you have to do? You have to slowly add pH 6.8 buffer solution together with 220 ml of distilled water into 50 ml of Leishman solution. and then you have to leave for 10 minutes. This is how the Leishman stain is prepared. Now talking about the safranin. Safranin is used as a counter stain for the gram staining. It is a biological stain. It is used in the histology as well. It is used for the cytological process also, and it is used in the bacteriology also in the gram staining. So it is used as a counter stain in almost the protocols wherever it is used. Alright, it provides the nucleus with red color. This is the counter stain, classic counter stain in both the gram stain and the endospore staining. How you have to prepare the safranin? You have to add 20 mg of safranin powder to a 100 ml beaker. After adding, you have to pour 20 ml distilled water in the beaker and make 0.1% safranin staining solution by continuously stirring the mixture. Now you have to transfer 20 mg of fast green dye in another 100 ml beaker. You have to filter both the staining solution to avoid particles. This is how this safranin solution is prepared. Now talking about the sodium hypochlorite. Sodium hypochlorite is a chlorine oxoanion, a chlorine oxide and a monovalent inorganic anion. It is a conjugate base of hypochlorous acid. So why sodium hypochlorite is used? Sodium hypochlorite is generally used for the disinfection of the laboratory. It is a disinfectant. It is a highly effective disinfectant which is used in the laboratory for the disinfection of shelves or different things in the laboratory. How it is prepared? The hypochlorite salts formed by the reaction between chlorine and alkali and alkaline earth metals hydroxide. So how we have to mix it at the room temperature so that the chlorates are not formed in this process. So how it is prepared? The sodium hypochlorite and calcium hypochlorite are mixed together, and thereby we will be getting the sodium hypochlorite. So sodium hypochlorite is like prepared in different concentrations such as 1%, 3% and 4%. Now talking about ethanol. Ethanol is also called as ethyl alcohol, grain alcohol or simply alcohol. It is an organic chemical compound. It is a simple alcohol. Alright. So it is a volatile, flammable, colorless liquid which has a characteristic wine-like odor and it is pungent in nature. Alright. Ethanol is also used for for preparing different types of solutions which are not dissolved in the water. As well as ethanol is used as a disinfectant in the laboratory. Alright, this is clear. Now talking about formaldehyde. So formaldehyde is generally used in the histopathology for different types of tissue processing. In the different tissue processing processes, formaldehyde is used. Formaldehyde is also used as a fixative in the histopathological laboratory. It is a naturally occurring organic coexist with the formula CH2O. Alright. It is pungent smelling, colorless in nature. The common name of this substance comes from its similarity and relation to the formic acid. Alright. How it is performed? It is performed by adding the methanol and formaldehyde in the presence of oxygen. That it will react at 250 to 400 degrees Celsius temperature in the presence of iron oxide in combination with the molybdenum and vanadium to produce formaldehyde. Now talking about preparation of different types of media and sugar that are used in the laboratory for different types of tests such as biochemical tests, the different types of biochemical tests such in the microbiology laboratory as well as in the biochemistry laboratory, such as dextrose sugar, fructose sugar, glucose, lactose and maltose. So what is dextrose? Dextrose is a white soluble sweet tasting crystalline solid. Alright. It is also called as D-glucose. Alright. So it is also used in the analysis of different biochemical characteristics in the biochemistry laboratory. So how you have to prepare it? You have to boil 200 gram of sliced unpeeled potatoes in 1 liter of water for 30 minutes. Then you have to filter this through cheesecloth, saving effluent, which is potato infusion. Then you have to add dextrose agar and water to effluent. Boil to dissolve completely. Then you have to sterilize the media by autoclaving at 121 degrees Celsius for 15 minutes. Then after the autoclaving and cooling, you have to aseptically dispense into sterile petri dishes. Now fructose sugar. So fructose sugar is also a white crystalline water soluble sugar which occurs in honey and many fruits. Alright. It can be prepared by the hydrolysis of sucrose in the presence of enzyme invertase or dilute sulfuric acid. It is a laboratory method of preparation of the fructose. Next, talking about glucose, which is very important. It is a white crystalline monosaccharide sugar which has several optically active forms. Most abundant form of it is dextrose, which is a major energy source in the metabolism. Glucose is also used for performing different types of biochemistry tests. Alright. Lactose is also a white crystalline disaccharide which occurs in milk and used in the manufacture of pharmaceuticals and baby products. It is produced from whey, which is a byproduct of cheese making and casein production, by crystallizing an oversaturated solution of whey concentrate. Alright. Now talking about the preparation of different types of media. So different types of culture media are used in the laboratory for growing the bacteria and isolating it. So the culture media are classified based on their physical state as liquid media, solid media and the semi-solid media. So what is liquid media? As the name suggests, that this is liquid in nature, fluid in nature. It is generally placed in test tubes, for example the nutrient broth. The liquid media is generally in the form of broth. Next is solid media. So solid media is prepared by adding the solidifying agents such as gelatin or agar to the liquid media, to the nutrient broth, such as for example the nutrient agar. It is generally placed in the petri dishes. Then there is semi-solid media. So in what we do in semi-solid media, we reduce the amount of agar or gelatin that we are using to solidify the media. Generally 0.2 to 0.5% is used so that the medium remains semi-solid. Such media are fairly soft and are useful for demonstrating bacterial motility and separating motile from non-motile strains. So for liquid media, example is peptone water. Peptone water is generally used for growing the bacteria and as a base for carbohydrate fermentation media. It is a broth medium which it is also used for the detection of indole. Alright. How we prepare it? We add 10 grams of sodium chloride, 10% of sodium chloride, 5 grams, and add distilled water up to 1000 ml. Alright, this is how the liquid media, the peptone water is prepared. Then you have to mix it properly and sterilize by autoclaving it at 120 degrees 1 Celsius for 15 minutes. So nutrient broth solution now, it is also a culture medium which allows a liquid or gel to provide all the nutrients that are needed for the bacteria to grow successfully. It includes carbohydrates for energy, nitrogen for protein synthesis and other minerals also. So nutrient broth consists of peptones 10 gram, beef extract 1 gram, yeast extract 2 gram, sodium chloride 5 gram, and the pH is maintained at 6.8 plus minus 0.2 at 25 degree centigrade. You have to add 13 to 15 gram of nutritious broth powder in 1 liter of distilled water. Mix and dissolve it completely. Then you have to sterilize it by autoclaving at 121 degrees Celsius for 15 minutes. So after like sterilizing it, the media is put into the different test tubes, sterile test tubes. Next is solid media. The example of solid media is nutrient agar. Here we are taking. So it is generally used for the growing of the bacteria and isolating it from this media. So it is used for the cultivation of microbes, which supports the growth of a wide range of non-fastidious organism. Alright. It is used for the growth of different types of bacteria and fungus. The ingredients of nutrient agar are tryptone 5 gram, meat extract 1 gram, yeast extract 2 gram, sodium chloride 5 gram and bacteriological agar 12 gram. Then what is the preparation? You have to suspend 28 gram of nutrient agar powder, that is commercially available, in 1 liter of distilled water. You have to heat this mixture while stirring it so that all the components of the nutrient agar powder are dissolved very well into the distilled water. Then after mixing, what you have to do, we have to autoclave it at 121 degrees centigrade Celsius for 15 minutes. So once it is autoclaved, it is allowed to cool but not solidify. As it reaches a little coolness or a little close to the room temperature, you have to pour the nutrient agar into each plate and leave the plate on the sterile surface until the agar has solidified. Then replace the lid of each petri dish and store the plates in the refrigerator. Now talking about the semi-solid media. So the semi-solid media, in the semi-solid media, the solidifying agent that is used in a lower amount. 0.2 to 0.5% is generally used, which will render a semi-solid medium. Alright. So it is used for the determination of bacterial motility generally. Alright. So Hughes and Leifson's oxidation fermentation test medium as well as mannitol motility medium are some of the example of semi-solid media. Certain transport medias are also used as a Stewart's and Ames media. Alright. So how it is prepared? You have to suspend 12 grams of the powder in 1000 ml distilled water. Then heat to boiling so that all the components are dissolved properly into the solution. Then you have to dispense in the tubes that are used. Then you have to sterilize it by autoclaving it at 121 degrees centigrade for 15 minutes. Then allow the tubes to cool in an upright position. After cooling, the tubes are placed into the refrigerator. So this is how the different reagents are prepared and stored in the laboratory. This was an introduction to the different laboratory reagents that are stored and placed and used in the laboratory. Hope all the concepts of these reagents are clear to you. If you have any query or doubt regarding these reagents, you can drop down your queries into the feedback section of the LMS. Thank you for joining, students.